Hello, George Romanic here. Today we are continuing exploring the beauties of Coriolis force, and we are solving part B of the problem that I introduced in the previous video, and you can see the problem on your screen now. Let's first explain some of the very basic concepts of how aircraft fly. So if this is height, Z, and this is Earth's surface, let's say we have aircraft like so, then weight of the aircraft, weight mg, is pulling this object towards the Earth, and there has to be counterbalancing force, which we call the lift force, that is keeping this aircraft airborne. That's how aircraft fly. Now this lift force is basically pressure gradient force, as we will learn later in this channel, and it's a consequence of wings of the aircraft having particular shape that causes pressure gradient force in the vertical direction that is just the right in magnitude to counterbalance the weight. Now, by changing the aerodynamics of wings, pilot can introduce more lift or decrease lift, and that's how aircraft take off, land, and do all kinds of maneuvers. So in this case, what is the maneuver that needs to be established in order to counterbalance this force? Well, let's just review what we found in part 1, or A. Here is Montreal, here is Belgrade. Aircraft wants to go from Montreal to Belgrade, but Coriolis force will deviate it towards the right. I should say due to F Coriolis, deviation towards the right. So now, if we look into the direction of this flight, this is usually how they put eyes, we look into this aircraft, what are we going to see? Let's plot it here, or here. If this is the tip of the aircraft that is now flying into me, the aircraft needs to be inclined like so in order to create component of the lift in the y direction and y direction. So this is x, this is y is positive northward. Because Coriolis force is acting towards the south, aircraft needs to be inclined like so, where this is y, this is north, this is height z, and the x-axis is sticking out of the blackboard. So when the aircraft is inclined like so, it will counterbalance this Coriolis force and have a straight line from Montreal to Belgrade. Well, this angle is beta, bank angle of this aircraft, namely angle between the vertical caused by the gravity, namely caused by the weight, and the vertical in respect to the inclined aircraft. If the aircraft is not inclined like so, then these two are the same and the bank angle is 0. Well, this is the vertical component of the lift force, and this is a force, namely horizontal component of the lift force, that needs to be exactly same in magnitude as Coriolis force, but opposite in direction, to create counterbalance. Well, what do we have here? We have that tangent of this angle beta let me write, tangent of this angle is opposite over adjacent, and opposite is horizontal component of the lift, which has to be exactly in magnitude as our Coriolis force in the y direction, and adjacent to this angle is just vertical component of the lift, but vertical component of the lift is weight, and weight is mass of the aircraft times g, where g is gravitational acceleration, intensity of this. So that is equal, well, we saw m of the aircraft times F times U from this equation and from part A of our problem, divided by the intensity m A times G. Mass of the aircraft cancels, and we get that this is equal Fu over G. But that's tangent of this angle, so angle is therefore arctangent of Fu over G. You have to know that G is 9.8 or 9.81 meters per second squared. So if you plug in these numbers, F we already calculated a million times, so I'm not going to do it again. U is given, G I just wrote. So if you calculate these, you will get 0.128 degrees. If I calculated this correctly. And this is the angle that the aircraft needs to have in respect to the local vertical in order to counterbalance Coriolis force. As you can see, this is extremely small angle, and that's why passengers don't feel it. You fly in the aircraft long distance, you don't feel like being inclined or anything, because the angle that autopilot or a real pilot, I don't know, needs to establish is very small. Now, interesting thing to discuss. If the Earth is rotating way faster, if the rotation of the Earth was way faster, omega would be larger, which means F would be larger, which means to tackle the same problem, the aircraft would have to be way more inclined in order to counterbalance Coriolis force. Fortunately, our beautiful planet has angular velocity that it has, 7.27 times 10 to power negative 5 radians per second, and therefore the bank angle is not so severe. And that's why you don't even notice it. However, it has to exist, otherwise you would end up south of Belgrade. If you fly from Belgrade to Montreal, you would end up somewhere north, or most likely you would never even reach this longitude. You would just make an inertial circle. What is inertial circle? Check my video on inertial oscillations. Until next video, goodbye.